I just posted homework 6. This is homework 6 right here. Well, I just posted homework 6. Homework 6 is just getting SDL compiling and working on a basic project that you are going to create. The goal is like you just create 2 files, and one of them will just be a basic test window application that you're probably just going to ask ChatGPT to write, and then you'll need to write a CMake lists or a makefile, and that is kind of the more maybe complicated aspect of this assignment is making sure that it all compiles. Another thing is you might have to, if you're on Windows, you might have to battle getting X11 forwarding working. I'm not going to spend time going over it in lecture, but just know that it is quite challenging. And using Pandoc and Markdown to generate your PDF for you. That's going to give you the nicest, kind of cleanest look. I would just recommend just getting practice using Pandoc and Markdown. So that's what I would recommend to make the PDF. Yes, question?
What extensions do we need to set the art department environment setup?
Yes, exactly. Yeah, so it is up to you. It is up to you to figure out how to get this working on your computer. So if you are on a Debian version of Linux, you might need to apt install some things. If you're on macOS, you might need to do brew install. If you're on an Arch distribution, then you might need to do, does anyone know what Arch uses? Yeah, Pac-Man, or I think there's something else for like Fedora or something. So yeah, depending on your computer, because you bought your computer, you are using your computer, so it is your responsibility. Like, you are stuck with your computer. You have to be the one to figure out how to get your computer to work. So yeah, so this assignment is basically just get this like very basic program working. Let me show you what I'm expecting the output to look like. Is this? Let me see. I may have closed it accidentally. Is it? Hold on. Give me just a second. Sorry, I think I accidentally closed it. Okay. Yes. Okay, so here I have my implementation. It's in this source folder right there. I won't show you my CPP file, but it's pretty straightforward. Basically, just ask ChatGPT, and it'll spit out like 30 lines of code, and it'll figure it out for you. And then I have my CMake lists, which will also be pretty easy for probably ChatGPT to make for you. But if I cd now into build, and then I can do make, and so it's making, and then I can do /test window, and there we go. So this is my window. I can move it around. I can't resize it. I can't do anything with it. But now I can hit X, and it closes out of it. So that is what this assignment is just getting a window working. Okay, like if we take a step back, though, and we're like, okay, like creating a window, has anyone been able to create like a window ever, like on any sort of application? Like, okay, so maybe like half. Yeah. Well, to create a window on like an operating system is actually like a fairly complicated task. What is a requirement in order to open up like a window? Like maybe start thinking like what is kind of like abstractly, or not even, maybe not abstractly, like what are the actual implementation things that are needed in order to create a window? Because like in our case, we're probably just going to do like create window, but the APIs that it needs to call like below that are quite complicated. Okay, so did anyone have any ideas? Like what needs to be done in order to create a window? Yeah. A buffer? Okay, Vulkan. So Vulkan is not necessarily used for creating windows. Vulkan does have wrappers that can create windows. But yeah, Vulkan is a graphics API that is used to, once you already have a window, then it draws like a pretty picture to it at a very high speed. That's the point of graphics APIs. If you have a graphics card, it's assuming you already have a window, now draw a pretty picture to it. Okay, but how do you create a window though? What is a window? Okay, what is the usual way that as software programmers we usually interface with our code that we've written? What's the main way? Yeah, keyboard specifically, what is the application that we use? What was that? Yeah, I'm thinking Bash. Usually we interface with our application with Bash, right? Usually we do / something we can type in, do cin, cout. Cin meaning console, right? Okay. So yeah, that is one way of interfacing with an application. The other way is through a window, right? So let's say the people making the first computers, they probably just started with mainly just text, text entry. And then someone had this beautiful idea. It's hey, what if instead of just typing everything in, maybe we had something that was a little bit more accessible and had pretty pictures. So what would someone have needed to have done back then in order to have it transition from just straight text but to creating a window? What needs to happen? Yeah? Yeah, okay, yeah. So a GUI, graphical user interface, yeah. That's the goal, right, is to, instead of having a command line interface, to have a graphical user interface. Yeah, another comment? Yeah, I like that too. Yeah, so if you wanted to stay within Bash, stay within your terminal, you could just draw everything using actual characters. Yeah, okay, and that would probably work. Yeah, well, what ended up happening is as operating systems became more widely used by people, they realized that you don't really want to just type into a straight terminal. You don't want to just type it straight into a console. Even though you can make pretty pictures, if you want using just ASCII art, just characters on the screen, even that is kind of a pain. And so what people did is, they would have some sort of GPU or something, some picture processing unit that then the operating system itself could now could call. And so now instead of having a command line interface, now you have a whole desktop environment. Have people heard of desktop environments before? Okay, yeah. So a desktop environment is just another application, and that is what makes the computer look so nice. So yeah, even though I don't know, it's kind of a weird kind of thing to think about, but all of our computers are actually running a big application on the front of it, which is the way that our windows are being assembled on the screen. And you can probably think every time I click on something, that's probably sending some sort of message to this desktop environment application. And if I click and drag, then that's sending some other sort of instruction to our desktop application. I can drag things over. Or yeah, if I click on things, then it sends messages now to maybe you have some idea of a window inside of your desktop environment. So yeah, a desktop environment is just an application that takes up the full screen of your computer. Now instead of it just being text that you enter into the screen, now it is this big canvas that is filled from the entire top of your screen to the bottom of your screen, where every single input that is from your mouse is being sent into your desktop environment, and then there are windows and things that you can manage within that. So if we now wanted to create, if I was now, okay, let's say I bought a computer and it comes with this nice desktop environment. For example, this is the Windows desktop environment. which is separate from like the Windows operating system. The Windows operating system controls like processes and file formats and file structures. But yeah, specifically the desktop environment is responsible for Windows. So okay, so if I wanted to now create a window using the Windows desktop environment in C, what would you imagine I would have to do now? And this also links in with our idea of like talking about third-party libraries. Yeah. Exactly, you interface with the Windows API. Yeah, which is like interesting because so Windows has done this beautiful job of making us the desktop environment for us, and now we can just be like, hey, Windows, can I actually have my application now also create a window within your graphical like interface? So that is the idea of desktop environment, and that is what a window like is. A window is just, it's like a single, you can almost think of it as like an element in a vector that is probably inside of the Windows desktop environment class or something. So cool. So that is effectively what needs to happen when we create a window. Is we call the Windows API. But calling the Windows API is kind of a pain. The reason for that is because Windows is like constantly updating. And also, like if you want it to be cross-platform, if we want to open a window on Windows, but you also want the same code to now open like a window on macOS or Linux or something, then maybe you don't want to directly ask the Windows API, just specifically like the Windows desktop environment. Maybe now instead you want to use a cross-platform like window creator that, can work for Windows, but it can also work across other things. So that is where SDL comes in. SDL is the GUI library that we will be using for our final project. And all it basically does is it will create a window for you, but it will create a window for you no matter whose desktop environment you're working off of. It doesn't matter if it's Windows or macOS or anyone else. Yeah, so that is what SDL is, and it stands for, I think, Simple Direct Media Layer or something. I don't know, something like that. The whole point of it is that it's a cross-platform way of creating windows. Okay. So yes, hopefully that kind of, I don't know. I kind of like that spiel of like kind of explaining like what a desktop environment is, because usually we don't really think about that. Usually we just think of it as I don't know, that's just our computer. It's like, oh, you buy the computer and then it like looks like that. But actually, this is like an application that is run. Cool. Okay. So that's the first kind of tangent that I want to talk about. The next thing I wanted to mention are some standard bugs that I'm seeing people are running into with their final projects. So I'm going to transition to that really quick. Feel free to ponder desktop environments, ponder Windows. Maybe discuss with the person next to you for a little bit. See if you can ask them. It's like, wait, so what's a window again? How does it relate back to the Windows API? Go and chat about it for just a second while I transition. All right, this next bit, I wanted to revolve around this question, because at this point, I've seen 4 groups be completely lost and beside themselves with confusion about why their final project does not work. And the reason was that their shift instructions were not working correctly. Okay, but I guess by a show of hands, how many of you, like just on a regular basis, maybe for like every single C++ project that you write, how many of you do the bit shift operation, like just all the time? Yeah, okay. Or raise your hand if you know what the bit shift operation is. Okay, cool, yeah. But you don't use it too often, right? Okay, yeah, okay, sure. But for some reason, the shift operation, or the shift instructions are still important, though. Can anyone think of a use case when assembly may just insert shift instructions, even though maybe you didn't ask for them, but just like put them in there? Yeah. Multiplication? Sure. Yeah, I like that, sure. I don't think that is what, there's no multiplication that takes place in our Banana Slug emulator in the Hello World projects, but sure, multiplication absolutely can use shifting in its algorithm. Okay, any other ideas? Yeah. Okay, yeah? Sure. I don't think the Hello World is doing that, but absolutely, yes. So you probably all used shifting when you were decoding out the different segments of your instruction. Maybe when you were grabbing like the, reg A, maybe you had to shift it by like 20 bits or something. Or if you were grabbing the opcode, maybe you shift it by 24 bits or something. Yeah, okay. Yes, but that's not necessarily instructions that are in your slug file. Okay, now I want to propose. Okay, so what is this instruction that I have right here that I've written out? What is this? Yeah, so load byte unsigned. Okay, so if we load byte unsigned, and let's say we load it into register 1. Okay, and let's say the value that we've just stored, so stored OXFF in register 1. Okay, OXFF, what value is this in decimal? This is 255, yeah. What if we now wanted, so maybe yeah, this is 255, or maybe actually this was supposed to be -1. And so maybe instead of a load 8 instruction, a load 8 unsigned, how could we somehow create a load 8 instruction? So instead of it storing like 255, instead, what would this value store? Assuming that this was, so it's not unsigned, instead it would be signed. So what value would be stored in register 1 at this point? So I'll say stored, whatever, in 1. So what value is this? If it was a signed number. Okay, so if we have a signed byte, right, so that is going to be 8 bits, and if it's FF, then how many of those bits are 1? Yeah, it's going to be all of them. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this number right here, yeah, it's 255 if it was unsigned. If it was signed, then this number would be what? Yeah? What was that? This would not be 128. Okay, yeah? This would not be -128. Okay, question for you. So if we were to add 1 to this, what would this value be? This would be 0, yeah. 2, 3, 4, 5, 6, 7, 8. Okay, so if we take this signed number and add 1, becomes 0, what is this probably equal to? Yeah, so this is actually -1. So in this case, when we store like FF, if it was a signed number, then this would be -1, yeah. Okay, so now the question is what if, we now wanted to create this load 8 instruction using other instructions that we already have. And I'll give you a hint. So remember, so we have shift, yeah, right? Shift, and then SLL, and then SRA. Is that right? I think so. Yeah, so these are our 3 shift instructions. Okay. Do we remember what the difference is between the A and the L? What does the A and the L stand for? Okay, I'll pull it up. These are maybe kind of just important assembly lingos that you should be aware of. Okay. SLL. Okay, so SLL is shift left logical, and logical, in other words, means that this is a wait, am I doing this wrong? Sorry, is it SRA, SRL? Oh, I'm sorry, it was SRL, okay. Thank you, were you all wondering that? Okay, good, SRL. Yeah, so the difference between A and L effectively is signed versus unsigned. So when we do a, okay, hold on. Okay, I'm getting ahead of myself. So, okay, shift LL, SLL. Remember, so this is shift left logical, SRA. What did I just do? This is terrible. Okay, it's fine. And then this is logical. Okay, so these are our 3 instructions. So we have shift left logical, shift right arithmetic, and then shift right logical. Okay. What are the differences between these 3? Okay, so if we do okay, this is good. So if we take this -1 right here, let's perform a shift left logical by 1 position. What will this now look like? So if we shift it to the left, then there's going to be a 0 now at the end. So 1, 2, 3, 4, 5, 6, 7, 8. Right? Good. Okay. And then shift right logical. Maybe this makes more sense first. So let's now do this same -1, and then shift right logical by 1. This now, it moves it the other way. So instead of shifting it this way, now shifts it to the right. So now this becomes 0, 1, 1, 1, 1, 1, 1, 1, 1. Okay, good. Now, what happened to this value now? So remember, so this was -1, but what is this value? Oh, yeah? Yeah, so this would be 127. So so you said if this was a signed number. What if this was an unsigned number? I think it's the same, right? So no matter what, it is always going to be, at 127. So when you have a logical shift, this, in other words, like treats the number as unsigned. Okay? In comparing that with shift right arithmetic, what happens is we preserve this top bit. So when we shift it over by 1, we actually keep this 1 right here. See that? So we keep this 1. And so therefore, this stays -1. Okay. Now, take a second, brainstorm with the person next to you. How can we now combine one of these, or a couple of these shift instructions and this load byte unsigned to now create a load 8 signed instruction? Okay, chat with the person next to you. Yeah, question? Thank you. Yep, A. Yep. Yes. Arithmetic means that it treats it as signed. Thank you very much, yeah. Okay, take a second. How do we implement now load 8 signed? Okay, it is dead silent in here. Any thoughts? Okay, yeah. Oh, if you do, you're saying right here? Then this would be the same value, yeah. It would still be all ones, yeah. Versus like here, this would be like that, yeah. It maintains this the top 2 bits no matter what, yeah. Okay. It doesn't modify it if the value happens to be -1. Yeah, but if the value is like -2, then yes, it will. Or -4, then yes, it will. Okay. I'll also mention, this is also maybe not the best example because here I'm assuming that the input to SLL is 8 bits, but in truth, what is the actual input? Like, what are the sizes that we're dealing with here? Yeah, so these are usually 16-bit values. So this load 8 is 8 bits, but this shift is operated on 16 bits. Okay, any quick thoughts before I give the answer? Can anyone beat me to the answer? Yeah, how can we use these shift instructions to do a load 8 signed? Yeah. So all of your conversations, you couldn't think of anything? Okay. Well, that's okay. Here. Okay. So let's say, first let's do load 8 unsigned. And yeah, maybe we'll load this, I don't know, yeah, just to register 1 or something. Okay, so this is the first step. So now, let's assume that maybe we're loading -1. So what we have is in our value, remember, so now we have a 16-bit value. So this will be, 1, 2, 3, 4, 5, 6, 7, 8, and then 1, 2, 3, 4, 5, 6, 7, 8. So this is the value that we've just loaded to register 1. Okay, well, remember that any time that we do a right shift, a right arithmetic shift, that we preserve the sign bit. Well, here's the sign bit over here. It's all the way over here. So is there a way that we could just like push this number to now have it be so that this index is in fact the sign bit? Okay, yeah? Sure, okay. So we could take this number and then shift to the left by 8. And so now this value becomes this, except now like this, right? So now we've just shifted it over, okay. Well, now we've just multiplied our number by like this huge value. Okay, so what do we do now to correct this? We probably have to shift it back, right? Okay, do we shift it back with shift right arithmetic or shift right logical? Yeah, arithmetic. Okay, cool. So then after that, so it's going to be shift right arithmetic. And look at this. So when we go and shift over all these values, these are all going to be 1s inserted at the front. So okay, so this value right here, when we have all 1s, what is this number? This is -1. So cool. So we have succeeded in loading -1 from this load 8 unsigned. So there we go. That is what is happening behind the scenes in all of your hello worlds when it calls all of the shift instructions. So you may not think like shifting is all that useful, but actually you'll find that maybe like a third of all of the instructions that like are running by by your emulation are going to be these shift instructions. Okay, kind of makes sense? So yeah, it's crucial that you get these right. So really, really double check that these are working. Okay, yeah, question? Yes, yeah. If you have Hello World 1, 2, and 3 working, it means that you've succeeded here, yeah. Okay. And since there's not many of you in this room, if you see people on Piazza who are frantically like, oh, I can't get it working, well, now you can kind of be a little like, oh, like, hey, have you double-checked your shift instructions? You can go and respond to them now, and they'll probably be like, wow, like, thank you so much. Like, I didn't know that was, like, the problem. And it's like, yeah, well, you should have showed up to lecture. So, another question? Are you good? Yeah. Okay, cool. So we're going to move back to SDL stuff now, unless there's any more questions on this. Okay. Okay, just one quick moment. Okay. All right. So on Monday, we talked about shared libraries versus static libraries. Okay, what is the benefit of a static library? Benefit of a static library? Maybe someone else. Okay, wait, ask the person next to you. What's the benefit of a static library? Okay. Well, what is a static library? Static library. Okay. Yeah.
A library that's compiled with the main file.
Not quite. A library that's compiled with main files. Not quite. Close. Okay. Yeah.
If I remember correctly, it's like we don't want to download the entire project, so we're just getting values.
Right, so that is not static. That's talking about a shared library, right? So the idea with a static library, right, if you remember on Monday, so we created the .o files, okay? The .o files are considered static objects, and when you link all of your .o files together, that is what creates the executable. And when you link in .o files, what effectively happens is you just concatenate all of your .o files. So then your executable is going to be really big because you have all of these .o files. So that is what a static library is. Okay. How is that different from a shared library? What is different? Yeah. Not quite. Still not quite. So a shared library, it's not a .o file, but it's a .so file. And the idea with it is when you compile the .so file, what happens to your binary? Okay, yeah? Yeah, right, stays the same size. I mean, it gets hair a little bit bigger. What is inserted into your executable file? Yeah? Exactly. It's just a link to the shared library. It's saying like, hey, I need this shared library in order to run. So when you run a program, when you do /create window, and if you are using a shared library, the idea is your create window like executable may have just like a link to SDL, and it just says like hey, like I don't have SDL, but like can you just go and install SDL for me? And then once you install SDL, and then you can type in like create window, and then it will actually call the SDL library. And notice that's different than a static library, because the static library, the entire library is embedded into the executable. So when you run like create window with a static library, then you don't need to install anything extra. Yeah. Okay. Yeah. Another. Yeah. So a .a file. I don't think I give a good explanation of it off the top of my head. But yeah, it's an archive file. You may also see that what a .a file is. It's another collection of object files, and yeah, it's just a collection of object files, but it's not an executable. Yeah, so it concatenates a bunch of object files. Yes, but it's not an executable. Yes, you may see a .a file, and .a file is basically a .o file, except it has multiple CPP like compilation units. Okay. Okay. Yeah, another input.
So like for the shared library,
Yeah.
it's like when you're saying, for example, the STL, like you don't actually have STL code like in your machine, right? Like you're calling it from some remote, like I don't know.
Sure. So I mean, you have it on your machine, but it's not in the executable itself. Like it's not in the like .exe file, or it's not in like just the executable elf file.
Is it somewhere else on your computer?
That's exactly right. Yeah. So when you have a shared library, the code for your for your third-party library is just in a different spot on your computer. And you often will get that shared library by doing maybe like apt install. Okay. So yeah, so for example here, okay, yeah, sure, okay. So here I have this main.cpp, okay, and I am including SDL2/SDL.h. And so this is a library that I have on my computer. I've sudo apt installed it, and you can see I'm just doing like init, and then I'm doing quit. This isn't actually creating a window, but it's just initializing a bunch of things for me. And then this is the way that I compile it. And the way that I compile it is with these SDL flags right here, which we can print out if we want. So we can say like echo, okay, so cd makefile, yeah, cool. That's not make clean. Okay, cool. So yeah, when I type main, make, you can see that. So in order to compile this, I need to specify the location of this third-party library that I'm bringing onto my computer. And I'm specifying it by saying right here. I'm saying like this is the name of the library. So it's called. Does anyone remember what this will elaborate out to when you have -l when you run G++ on this -l thing? What file is it looking for? Yeah? Sure, so it's a .so, but the full file name will be like lib sdl2.so. So if we wanted, we could like try to find this file. Actually, yeah, maybe we'll try to do this. So if I do /find/user, so I'm using the find command, and I can say look for this file. I can say lib sdl.so. And so now I can search for it. It might take a little bit because there's a lot of files in here. But in theory, at some point, this will exit as long as it's actually installed here. And we should be able to find our lib sdl2.so file. Yeah. Cool. But yeah, but when we compile this main, like if I didn't have SDL2 installed, then we would get a problem that says like, oh, like you don't actually have SDL2 installed. And that's what like, oh, cool. There we go. So good. So we can find, yeah, this lib sdl2.so right here. Yeah. And you know what? Maybe, yeah, let's do something kind of crazy. Let's move it somewhere. So we can take this. We can do sudo move. Actually, first I'll just quickly run main. So I'll show you. So main succeeded, no issues. Okay. But then I will move this shared library folder, the file, and I'll just call it .old or something. And it'll probably, yeah, permission denied. So I'll just do sudo. Okay, there we go. So now when I run /main, it still works. Okay, it's still finding it from somewhere. That's okay. I was hoping it was gonna. Well, that's okay. But if there wasn't like that protection in place, then what we would see is it'd be like, oh, like, hey, like, can't find this library. Let me go and move this back though. That's, yeah. All right, that was a little anticlimactic. Okay, that's okay. Let me show you instead shared. This will demonstrate my point better. Oops. Yeah, so if you remember, so this was the example from on Monday where we have this main, and so this calls foo, but foo is implemented in this third-party directory right here, and we can go and compile this as a shared library. So I can go into third-party, and I can make libfunc, is that going to work? func.so. So there we go. So now it's compiling as a third-party library. Then I can go back and I can compile now the, I can run make main shared. And now you can see that I've included this libfunc right there, which I just compiled right here. Yeah. And if I now go and try running / what's it called? Main shared, then, yeah, so this is what I was looking for. Now it says, like libfunc.so cannot find shared object file, no such file or directory. So this is a common issue that, yeah, you may run into if you don't have something installed but you're trying to access it, okay? So how do we fix this? Do we remember? So we have this executable. The issue is it can't find the shared library. So what we need to do is we need to specify it in our like load libraries environment variable. Yeah, so I can do. Let me quickly just find it so I can see what my load libraries has at the moment. If I just tab this out, load. Nope. Come on. Ah. No. Okay, sorry. Just 1 second. That's what it was, yeah. Okay, so it's this load library path. So if I were to echo this right now, you can see I don't currently have anything in this. But if I now set this to this third-party directory, say third-party, and then try running main shared, then you can see now it works. So this is just showing you that main shared does not have the shared library embedded inside of it. Instead, I needed to specify where this shared library existed on my computer in order for me to actually even use this. Okay, cool. So now let me ask my first question again. What is the benefit of a static library? Okay, yeah? Yeah, exactly. So static libraries, you don't have to do anything special. You can just like run it immediately. You don't need to specify, like you don't need to install anything extra. It just comes with everything. Okay. But then, yeah, what was the benefit of a shared library now? Why might you not want to use a static library? Okay. What was that?
Smaller executable.
Yeah, smaller executable. Yeah, cool. And you can also update your shared library independently of your static library. Yeah, cool. Okay, good. Now, let me show you another. Okay. Let me show you what CMake does to remedy all this. So, yeah, figuring out exactly where all of your packages are installed can be a little bit tricky. I will show you, yeah, once again, so the make file, what it does is it runs this SDL2 config right here, and this is really convenient. This just tells us, like, yeah, all the flags that we need in order to compile our program. So if I want, I could run this, and yeah, you can see. So this specifies the include files for all of our header files, and then this specifies the shared library, like .so file. But what CMake does, which is really nice, so here's a CMake file, is we have this find package function. And what find package will do is you just specify the name of the package that you're looking for, which is STL2, and then you just say that it's required. And then by putting this one single function in here, now it will fill out these very important environment variables. It'll fill out STL2 include directories, and it will also fill out STL2 libraries. So if I now run this instead, so if I do /stl cmake, okay, and now make dir build, okay, cd, let me remove that first actually, okay, good, cd build, okay, and then cmake ... So we can see it's fetching everything, and what it's doing is it's running each of these instructions. So yeah, so first it's checking the minimum version, then it's creating the project, and then it's running this find package right here. And then you can see it runs this message command right here. Message is the same thing as like echo. So if you ever wanted to debug your CMake file, you can do that. You can do it with message. So here, yeah, I'm printing out the include directory where all of the STL2 header files are. So if I wanted to see how to call STL2, I could, if I want, I could open it in VS Code. So, come on. That's. There we go. So this is the include directory for SDL. So you can see all of the different, all of the API that goes into running SDL. So you could look at SDL metal and whatever, all these random things, SDL test. So yeah, if you were wondering where SDL will be installed to your computer after you run sudo apt install, this is where it will be. And yeah, and we can find where the SDL libraries are as well. We can see that, I think it printed it out. Where is it? I guess it's in the same location, so that's great. So there we go. And by setting these paths, now we can run this command right here, which is target link libraries. And what that's saying is, so we put in our target right here, which is main, and then we want to link the library, which is STL2 libraries. So this CMake command right here, this will link our STL2 shared library into main. Yeah, and it's all kind of done automatically for us. What's nice is even if we if we didn't want to do STL now, but maybe we wanted to use WX widgets or some other popular C++ project. Now what we can do is just run find package and then target link libraries, and that's all you need to do. I guess, and then also include directories. So basically, these three commands right here, this is all you need to do in order to include any third-party C++ project.